So the different types of firewalls that are out there: packet filtering, application layer proxy, circuit level proxy, stateful firewalls. We're going to look at each one of these, and what you need to know is what layer they work at, what type of protection they actually provide. Now, I said earlier that in the industry, most firewalls aren't this straightforward. A lot of actual firewalls use 2 or 3 of these technologies together. But for the exam, what the exam is going to do is see if you know exactly what the different technologies are. What's a state firewall different from a proxy firewall? So there's been different generations of firewalls, and you need to know the generations. Generation 1 is a packet filtering, which is basically a router with ACLs on it. Generation 2 is proxy, which we'll talk about. Gen 3 is stateful, 4 is dynamic packet filtering, and 5 is kernel proxies. So we're going to go through each one of those, but you may get a question on which generation is packet filtering or something. Now, we actually kind of covered packet filtering when I went through routers, because routers will have ACLs, access control lists, that will make access decisions based on header information. So if you have a packet filtering firewall, it's going to look at the headers in the network, the information in the network header, and a little bit in the transport. So it can make its access decisions, and the network administrator configures based on source and destination IP address, the type of protocols that are used, where it is in the we'll talk about how the handshake, if it's a SYN, SYNAC, ACK, it can make those decisions. And it looks at port numbers. You could specifically say that any traffic going towards this address, port 80, you'll set up a rule because that'll be your web server. So all traffic will go to that port on that address. So that's why we usually say that a packet filter is a level 3 device. It is a level 3 device, but it also can make access decisions based on the source or the port number, which is actually in the transport header. So packet filtering is the first generation. It doesn't provide a whole bunch of security based on what the other ones we're going to look at. But again, it's usually that first line of defense to get rid of kind of all the garbage that we could easily get rid of. And then the other firewalls are usually behind it that do more processing and dig more into the actual packet itself and making decisions on if this is malicious or if it's allowed or not allowed. Now, the packet filtering firewall, I had said that you can, when you actually make up your ACLs, you'll say from a source IP address, and it could be any, or you could specify a range, or you could specify a specific port address going to wherever the destination is, in the actual ports that the packet's trying to go to. And I said that you can also do filter based on SYN, SYNAC, and ACK. But it doesn't actually keep state, which means it's not going to remember what came before it. So even if you say you allow, in your rule, you allow SYNs and SYNAC and ACK, well, an attacker can actually send a SYNAC. And we go through the actual TCP handshake in this domain. In a TCP connection, there's a SYN packet that's sent over, a SYNAC packet, and then an ACK. So that's the three-way handshake. Now, the packet filter doesn't actually keep track of the SYN, SYNAC, ACK, so it's not what's called stateful. So this actually can be fooled. I could send a SYN-ACK packet over to your system, and what your firewall, if it's packet filtering, it basically is assuming that there's already communication going on, because that's the middle of the handshake, SYN, SYN-ACK, ACK. So again, it doesn't provide as much security as the other ones, but Very useful, usually like your border routers that will provide this type of security. So since the packet filtering is only looking at headers, it can't detect if the data payload has any anything that's corrupt or malicious. So if there's some type of SQL injection attack or something like that, it won't be able to detect it because it doesn't read that far into the packet. Logging is usually limited on a packet filtering, and logging is very important to be able to piece back together what happened if there's been any type of compromise. And there's not really a lot of user authentication. It's usually based on the ACLs, what systems can talk to what systems. So it's just looking at the header information, and so it just has really a small criteria. It's a small amount of variables that it uses to make its access decision. So if we see here, you get a packet that will go through the firewall. The firewall will then compare it to an access control list, which is what the administrator configures. And it only looks at what's shown here, those actual headers. That's all it looks at. And so based on that information, it will make its access decision, and then the packet, if it's approved, it will go to the system that it's allowed.